So one of the things that our curriculum expects 3 honors students to memorize is the cofunction identities, which I think is stupid because we don't need to memorize these. We know the summation identities. And when you understand the summation identities, sines can't change signs, cosine changes the silly signs, all that. When you understand those, you don't need to memorize the cofunction identities. You can just reinvent them. Now, if you want to memorize these, that's fine. But I only have so much brain space, and I am not going to fill it up with cofunction identities. I'm just going to learn how to reinvent them as I need them. Okay, so if I ever see a cofunction identity, I honestly don't know what these are. I just recreate it. Okay, and I want to focus on sine, and I think cosecant would be another one. And once I show you how to do these, you'll be good to go for the rest. Okay, so let's do sine pi over 2 minus omega. If you remember the summation identity, which is a much more useful and powerful technique, we're going to say sine pi over 2 minus omega equals sine pi over 2 times cosine omega. Remember, sines can't change signs, so it's going to stay minus cosine, that's supposed to be a pi, cosine pi over 2 times sine of omega. Okay, that's my summation identity at work. Now, sine pi over 2, you know your unit circle, that's just equal to the number 1 times cosine of pi, of omega. Cosine pi over 2, you remember your unit circle, that's the number 0 times sine of omega. Now, 0 times anything is just 0, so we cross that out. And all that's left is cosine omega. So, for this one, we have cosine omega as your answer. And you can go through the same exact process for cosine pi over 2 minus omega and tangent pi over 2 minus omega to get those cofunction identities. Now, let's focus on cosecant, because we haven't actually talked about cosecant summation identities. There really isn't a cosecant summation identity, and that goes for the other reciprocals and quotient ones. But there is, I mean, look, you could make them, but they really would not be convenient at all. Instead of saying cosecant of pi over 2, I'm just going to point out to you that that is equal to 1 over sine of pi over 2 minus omega. And that may look a little weird to you, like, wait a minute, shouldn't I be flipping over the pi over 2 to 2 over pi or something like that? Well, no, the angle does not flip. Think about it this way. If I said, get rid of that. If I said cosecant of x, according to the reciprocal identity, that's just 1 over sine of x, right? It's not anything to do with sine of 1 over x or any nonsense like that. So that is not it. We simply do 1 over sine of the exact same angle. So now I have 1 over sine of pi over 2 minus omega. Now we just did all that work to say this is equal to 1 over cosine omega. And that is just equal to secant omega. So we just need to know our reciprocal identities, and that is real quick. Secant omega. Okay, there you go. Do the same thing for the others. You'll be good.